Hello everyone, this is another tutorial video. Today, we're going to create a tree shader that sways in the wind. And we'll be using both Blender and Unity Shader Graph for this tutorial, so make sure you have them installed. Without further ado, let's get started. First, we need to prepare a tree model that can be imported into the game. If you don't have a model ready, you can find the download link for the model I used in the video in the description below to download and test it. Now let's import the model into Unity. After placing the tree in the scene, you'll notice that it appears white because we haven't assigned any shader or material to it yet. So let's create dedicated shader graph files for the trunk and the leaf. Since my project uses the built-in pipeline, the menu might look a bit different, but it should be pretty much the same. Just select your pipeline and choose that lit shader graph, giving it a name you like, and then create another one for the leaves, also choosing the lit shader graph. After both shader graphs are created, we can start editing them. Just double-click, we can open the graph editing window, and right-click on the tab to choose to maximize it. And first we'll add a color variable to control the basic model appearance color. And we can set the default colors to white to prevent the model from turning completely black. And then connect it with a multiply node. We also need a texture variable to use our model's texture. Connect its color output to the multiply node, so the color and the texture color will blend together. And create another float variable for smoothness. Don't forget to set its mode to slider, so that it stays within the desired range. After clicking Save, we've completed the basic tree trunk shader setup. And next, let's create the shader for our leaf. The basic elements of the leaf shader are similar to the trunk shader. We also need a color parameter and a texture to project our image. And we remember to set the default color to white. Just like what we did before, multiply the two color outputs together and connect them to the shader's color output. Next comes the part that's a bit different. We need to set up the graph settings. Because the leaf's texture includes alpha values, we need to check this alpha clipping option. Next, to prevent only the front of the leaves from being rendered while the back is called, we need to choose double-sided rendering. Since I separated the color and mask into different files for the leaf texture, we'll need to use a mask texture. If you're using a texture that has both color and mask together, just connect its alpha to the shader's alpha output. And don't forget the smoothness values, create a float, and then set the mode to Silder. That pretty much wraps up the basics. Click Save, then we return to the Scene tab to use the shaders we just created. Right-click on the shader graph file and create a material. Remember to right-click on the file or your material won't use the shader you created. If not, you can still set the shader in the inspector to the one you created. Next, drag the material onto the tree trunk and leaves objects. We also need to assign the textures required for the trunk and leaves objects. Alright, now our model has its basic colors. We can now move on to create more advanced features, like wind swaying effect to our trees. To animate the model, we need to control the position offset of each vertex, which will simulate the effect of the wind blowing. So add a position node to our graph, which represents the position data of all vertices. And then connect it to an add node. And create a vector 3 to test how the offset works. Give it a name like offset, and drag it to graph and connect it to add node. Connect the result of the add node to the shader's position output, then click Save, and let's see the effect. It seems the tree's position is a bit off. Clicking on it shows that the origin and the model's position don't match, clearly indicating that the model's vertices have been offset. But when we click on the material, we see that the offset values are all set to 0, yet our model is still shifted. Clearly, something isn't right. Let's go back to the shader to figure out what's causing the issue. Actually, this issue is straightforward. We can see from the node information where the issue lies. our vertex displacement is calculated in world space, while the shader output expects object space. That's why the strange offset occurs. To fix this, we need to use a transform node. It allows us to transform the computed result between different spaces. Select converting from world space to object space, and connect it to our output. Now the problem should be resolved. Excellent. Now the tree vertices will only offset when we adjust the value, just as we expected. Next, let's use a time node to control the displacement. This means we won't have to adjust values manually, and the vertices will move over time. Right-click and search for time to add a time node to our graph, and connect it to a sine node. You might be wondering what the sine node does and why it's used to simulate wind effects, so let me use a math line drawing tool to illustrate it for easier understanding. First, our time node works like this x-axis. It continuously accumulates from the start of the game until it ends. When we plug it into the sine function, it would generate a wave. We can also control the wave's frequency and amplitude using operators. For example, multiplying x by a larger value speeds up the wave, while a smaller value slows it down. And by multiplying the sine calculation result by a value, we can control the wave's amplitude, which is its height. Now let's apply these features in the shader to simulate the wind effect. Since our calculations are in 3D, we need a vector 3 to control the wind direction. We'll use the previously created offset for this, connecting it to a normalized node to ensure its length is 1 so the wind's direction doesn't affect its speed. And then, rename the offset to wind direction. Now multiply the wind direction by the sine calculation result and add it to the vertex positions. This will give us a simple wind effect. Let's check it out in the scene. Uh-oh, sorry my bad. We didn't set a default value for the wind direction, so we can't see the vertices after the offset calculation. Now our trees will move with the wind direction. Let's add more parameters to control the wind animation. Let's move those nodes to clear some space, so that we have room to insert parameters. We need a multiply node here. And here, another one to control the speed of time. Now add 2 float parameters, one to control the speed, and with its default value set to 1 to avoid the previous issue. Another one to control wind intensity, also with a default value of 1. It looks like everything's fine. Let's check the scene to see the result. Now we can control the wind animation using the values in the inspector. Excellent. However, right now the entire trunk moves, which isn't what we want. We want the tree's roots to stay unaffected by the wind, so we need another value to control the movement range of the vertices at the bottom and top. There are many ways to get each vertex's height in a shader. Here, I'll show a method using UV projection to obtain the vertex height. If you've seen the previous grass shader tutorial, you'll recall we used a similar approach. However, since the tree model's UV is already used for texture projection, we must use the second UV to preserve the vertex data. Now let's head over to Blender to complete this step. First, import the model into Blender. I previously saved it in FBX format, so we choose FBX here. Next, we need to normalize the model size. Click one of them, hold Shift, then click the other to select them both. Press Ctrl and A, then select all transforms. Next, click on the tree trunk model, then click this green triangle. Find the UV maps and unwrap it. Then click the plus button to give it a second UV map. Select the leaves model, and then do the same thing to it. Next, let's project the second UV map. Before we begin, make sure that both models have the second UV map selected, and that there's a camera icon beside it. Select both the tree trunk and leaves models. Then go to the UV tab, press 1 or 3 to switch to a side view, press U, and choose Project from View Bounds. If you see your tree model projected in the side view as shown in the video, you're all set. Good job! Now, go back to the Layout tab and prepare to export the model. We still need to switch the UV back to the first UV map to avoid errors in Unity. Okay, now export the model. Choose format you want. Go to our project asset folder, confirm the file name. Make sure to check the Apply Transform option, click Export, and now we can return to Unity and continue. Switch to the Shader Graph tab and move these nodes to clear some space. Add a multiply node and connect it here. Next, create a UV node and make sure to select the second UV map. Connect it to the split node. We need the V component of the UV, which is the second output, so connect that to the multiply node's B input. Now the vertices in the tree's roots won't move, but it still looks a bit off. Let's add more controls to adjust it. Connect the smooth step node here to control the parts unaffected by the animation. This also requires a vector 2 to define the range. Remember to set its default values to 0 and 1. Then, use a split node to separate it and connect the outputs to the smooth step node's inputs. Now back to the Scene tab, click on the material, and go to the inspector. Find the vector 2 we just created, then test by adjusting the X value. Now the animation looks better. You can also adjust the range to suit your model. Now let's make the top branches sway more naturally. When we hide the leaves, you can see that the top branches are moving in unison, which isn't what we want. So let's improve that. If we want each vertex's animation to vary instead of being the same, we need to find what makes them different and use that to improve the animation. Fortunately, there's a value that differs for each vertex. That's the world positions. You can treat each vertex as an individual game object, each with its own world position. And each vertex's world position is unique unless they share the same position, so we can use that to add variation and make the animation more natural and lively. Now, in our graph, let's change the start time of each vertex animation. Connect an add node between these two nodes. Since the add node in Shader Graph only supports 2 inputs, we'll need more add nodes here. And add a position node. Just like before, use a split node to separate the X, Y, and Z values, then add them together and combine them with our animation time. This ensures that each vertex has a different start time. Let's back in the scene and test. It seems like the difference between each vertex is too small. Let's add a value to control this. If you add any animation control values, better to set the default to 1 to ensure it works properly. We can use a multiply node to increase the variation in each vertex's position. And now, let's adjust the value we just created. It looks like 0.1 works well. Let's adjust the wind speed also. It looks much better now. Finally, don't forget to add the same vertex animation to the leaf shader so both the trunk and leaves have animation. And with that, we've completed a simple wind-swaying tree animation. You can also apply this shader to models other than trees, such as flowers, bushes, or other small vegetation. Alright, that's all for this video. Hope you liked it. Don't forget to subscribe for more interesting content. See you in the next video. Goodbye.